My name is Kevin Cullinan and I'm a project manager for Sonoma Resource Conservation District. Resource Conservation Districts, or RCDs, are local, non-regulatory grassroots conservation organizations that work together with landowners and local partners to address their district's most pressing natural resource concerns.
In this video, we will be taking a look at an experimental demonstration project with 5 different headcut treatments to address channel erosion on the Pepperwood Preserve Property in Sonoma County. The 5 headcut practices we implemented include a willow wall, a rocked headcut repair, a rocked grade control structure, native grass plantings, and brush rows to brush check dam. RCD staff worked with restoration experts Prunuske Chatham to design these 5 erosion control practices and to create this video demonstrating where landowners may be able to apply these practices themselves in order to prevent or reduce erosion on their own properties. Many of these practices can be found in the Groundwork Erosion Control Guide produced by Marin RCD. This guide gives a great overview of erosion issues and provides several illustrations of common erosion control and bioengineering treatments similar to the practices implemented at Pepperwood Preserve. A link to view the Groundwork Guide is provided in the video description. Please keep in mind that depending on what kind of work you are planning and what water bodies are nearby, you may need to seek out a design consultant, engineer, and/or permits. When in doubt, please feel free to reach out to your local RCD with permit questions. This project was funded by the State Water Resources Control Board's 319H grant program and meant to address water quality concerns resulting from post-fire related erosion issues. Pepperwood Preserve burned both in the 2017 Tubbs Fire as well as the 2018 Kincaid Fire. Due to the less severe nature of these headcuts and their location high up in the headwaters of Pepperwood Preserve, this site was deemed a good location to install the 5 different headcut treatments to be used as a living experiment, which will help inform use of these types of treatments in other fire-affected areas.
Here to give an overview of the Pepperwood Preserve and the Gully Repair Project is Preserve Manager Michael Gully. Later in the video, we'll hear from Mike Jensen of Prunuske Chatham, who is going to break down the 5 site treatments.
My name is Michael Gully. I'm the Preserve Manager at Pepperwood Foundation. At Pepperwood, our team of scientists are out every day studying the land, the water, the wildlife, so that we can better educate decision makers, our community, and the kids growing up today. We're a 3,200-acre nature preserve in northeastern Sonoma County, and we're a living laboratory where we can test out our theories about how to best protect forests and landscapes and the wildlife. And so we collect data and do research every step of the way on all of our activities so that we can really demonstrate that we're doing what we want to and have the data to back that up. So this project that we're talking about today, the Gully Headcut Repair Project, we're high up on the hillside. So the creeks here are ephemeral. They just run in the wintertime. What we're seeing here is some erosion problems. When you have water coming down and it flows over an obstacle and it falls down, it has a lot of energy there. And as that energy is dissipated, it's eroding the ground around it. And that headcut slowly moves up the gully or the drainage. It's lowering the water table and it's creating sediment. It's going to run downstream where our salmon and steelhead are. So we're trying to correct those erosion problems.
Yeah, so this design is a modified willow wall, and we've been using willow walls for years for stream bank repairs, but it turns out that it's a pretty good technique for upland erosion control. And in this case, bioengineering projects like this, generally, it's safe to use them kind of in that 5 to 10 acre drainage range. You can use them in bigger drainages up to 20 acres. You start to get a bigger watershed, you probably want to start thinking about talking to a civil engineer or a restoration design professional. But these are really great because landowners can do this on their own with minimal tools and, you know, kind of a one-day project or a weekend project. So this project here, we start with willow posts 2 to 4 inches in diameter. They need to be at least 3 feet on center. Here we have them about 2 feet on center. Yeah, it looks like 24 inches. Generally, you don't want to be any taller than 3 feet tall. You want to have about 2/3 of them in the ground if possible. So a 3-foot wall, maybe 5 feet in the ground. That's about as far as you can dig with a post hole digger without getting into some kind of auger on a mini excavator or something like this. And they actually got into a little bit of bedrock down low, and they weren't able to get the willow posts in 5 feet, which is what we typically recommend. So what they did here is they used this other willow and some other staking with ropes, and they did what we call as a dead man. They might have tried a live man up there, which actually, by putting a soil anchor in, they can pull the wall back and hold it in place, and it's a little extra protection because they didn't get the depth they need to stop the wall from toppling over. And then we have a woven wall here where we're actually weaving willow back and forth to get a lot of tension to build a structural component for this wall. All these weavers here will grow. Generally, we like to use about 3/4 inch to 1.5 inches, but we'll take long branches and all the willows used. Small willow can be used for branch packing behind the wall, or used here. In this case, we have a brush apron here for energy dissipation. So once the willow wall is built, we want to retain the soil of this head cut so it can't wash through the wall. This was actually a nick point that was moving up this gully and had a potential to downcut and lower the water table in this entire valley here. So we want to control these nick points when we see them. And in this case, if we just did the woven wall, soil could still pipe through the wall. So this wall is actually kind of different. It was packed with these little coconut biologs or coconut wattles. They're 6-inch fiber rolls, densely packed with coconut husks. And what that does is allows the water to penetrate through them, but will retain the soil. So those are packed from top to bottom behind this wall that will stop the soil from migrating through the wall. This wall, there was a small head cut running up behind it, so they did some extra brush packing. You'll see live willow stakes sticking through the small gully that was running behind here, and then backfilled with soil so these can all sprout and turn into willow trees and provide roots to kind of slow the erosion over time. This head cut, you want to have a low flow notch on a willow wall to control the head cut so water doesn't do an end run around the sides. And so they actually did these little speed bumps here, just little berms of soil, little water bars, but wrapped in coir. So we call these fabric reinforced earth fills. They're encapsulated soil, encapsulated in coconut blanket. Lots of coconut here. And then this structure also has a bunch of live brush back down here that's creating a energy dissipation pool. So when water spills through the low flow notch over here during the winter, we would actually have a backwater condition where water lands into a pool and actually dissipates its energy before it spills over the riffle crest. And the downstream end of this energy pool has a riffle crest where the water spreads out, fans out, not concentrated, and then with its energy dissipated and then migrates down the stream. With this site, this is an upland tributary, so it is high and dry during the summer. So in this case, they do have supplemental drip irrigation with little misters. These are going to turn into dense willow thickets here that will create habitat. In some cases, you will not have a water source, and therefore you can plant drought-tolerant plants upstream and downstream of your repair. So as the willow dies out because it's thirsty for water, maybe there's coyote brush or other drought-tolerant plants planted just upstream that are more appropriate for the site. We love willow, though, for these bioengineering techniques because it's very flexible and it's a great building material. It provides a structural component here to stop this head cut while we establish other plants. We generally like to build these bioengineering projects or biotechnical projects in the fall and early winter. In this case, we're doing it in fall before October 15th to be within inside our permits. But we try to do it when the plants are starting to go dormant, so that really they're going to be throwing down roots and not trying to leaf out so much. And then we're also banking on some winter rains to kind of water this in, get the ground wet and moist so these plants, this willow, can be established. Different willow species we use. Common is arroyo willow, is a great willow for doing this type of work. It's very common to Sonoma County in the North Bay. We do use other willows like red willow or shining willow. Those will be more of a tree form. This arroyo willow is a little bit more of a shrubby tree, if you will, and it's really excellent for erosion control. So this site here is a loose rock head cut repair. There was a 2 to 3 foot tall head cut across this gully, very active. It was moving upstream into this nice native grasses and juncus up here. And the channel was down cutting, getting deeper, lowering the groundwater table, impacting the habitat upstream. We're also trying to stop all the sediment from moving downstream, especially in our areas where we've had fire, trying to retain some of these fine sediments upslope and not having all wash out into our lower watersheds where our fisheries are. So on this one, the head cut was approximately in this vicinity, and what they did is they laid it back at a 3-to-1 slope and then cut in a little bench for the rock keyway and weir. This one was dug out with a mini excavator to do the initial keyway and placement in here, and then they hand placed the rock. It was all using small rock because it's such a small watershed, and so this is something that a landowner can do on their property themselves. So what happened here is generally you build maybe a foot thick of rock, you sprinkle some of your class 2 perm gravel on. Class 2 perm is a gravel mix that allows water to run through it. It's very permeable. You hit it with a fire hose or a high pressure hose and blast it into all the voids. When you can see the top of all the rocks you've already set, you build your next layer of coarser rock to your desired thickness. And then rock is brought up to the top, individually placed and locked into place by hand for stability, so I can walk on a lot of these small rocks and they're pretty stable. The cool thing about loose rock is it's flexible. So if this does adjust, if we have some erosion moving upstream, this rock, say this thing needs to settle a little bit, the loose rock will settle into place and still maintain grade. When you design these, you want to make sure you're matching the size of the channel upstream. So this has a nice weir here, so water during a large storm can spread out across it safely on the rock, and then it's a transitional channel or slope to get back down to the lower gully down here. So we don't have a waterfall, we have water running on rock to stop any of the erosion. We like to install little flat spots or energy dissipation pools. This has a very small pool here, but it will slow down water here before it enters the main channel. Behind this rock weir here, on the back side of it's a 1-to-1 slope of rock. And behind that 1-to-1 rock slope, they've backfilled this cavity here with soil so it can't wash out. So this is a soil fill where the old head cut was, held in place at the subsurface level through this gravel lens. And then because it was a loose fill, they put coir blanket over native grass seed on top here. So this will all become a nice native grass bed here with perennial roots, deep rooting grasses to kind of control this area. This coir mat's really great. So up above, we were looking at coir blanket. Down here, we're looking at coir mat over coir blanket. Coir mat, generally we use 700 gram, which has some nice little voids that allows perennial grasses to grow up through it. It's really good stuff. It'll last 3 to 5 years on most sites as that grass is establishing. It allows your revegetation crews and stuff to walk on it during the winter when it's wet. Underneath this, because it does have these little holes, we do have a piece of the C125BN erosion control blanket, which is the classic coir blanket. It's a little denser fibers, so it holds the soil in place, but allows grass to grow right through it. The problem with that is it will fall apart during the winter if you're walking on it a lot with your boots and things like that if it's a soft site. So the two together are very common to use for bioengineering or stream restoration. In this case, they've used steel pins with washers, and this is a great technique to get the blanket nice and tight to the ground so there's no tenting, so the water can run right over and retain the seed and the topsoil in place. What we recommend generally is planting some native plants around the edge so all this rock kind of softens and disappears from the landscape forever. Some coyote brush, or down low here we could put some willow stakes in with volunteers, and all this rock would then potentially catch some sediment over time, fill in with organics, and kind of disappear and make a nice little piece of habitat. This is site 3. It's another head cut repair using a hand-placed small rock, a loose rock fill. And the difference between this site, they have many of the same elements, but this one was actually built with a rock check dam, which is a classic NRCS soil conservation design to capture sediment. In this case, we're not trying to capture sediment, it's a subsurface grade control. We've taken that old classic design that was used on many dairies and ranches with gully issues and put it in front of a head cut, and then behind the rock grade control structure, a soil fill was placed in up against the head cut or nick point to completely fill it in and stop the head cut from moving. So it's providing grade control at the crest of the head cut. It's built just like the rock head cut repairs. It has interstitial fill put in all the voids, water jetted in lifts as the rock comes up. All the rock was hand placed. It's nice to be able to do hand rock around stuff like this oak tree here. They didn't get in here and disturb the oak roots with an excavator or anything like that. They were able to get in and hand place rocks and seal up the voids underneath the tree. It's a nice way to save some of our native trees that might be undermined or things like that might fall into the creek if they don't have some extra support underneath their main root structure. So this is really great. Juncus is excellent for erosion control, and they're putting that actually on the keyway of the soil fill that's behind the grade control structure through the coir here with a little bit of their extra gravel on top. The Juncus, once it's established, it would take a couple thousand pounds of force to pull this Juncus clump out of the ground, while I can come up here and grab one of these small 20-pound rocks and lift that up. So the Juncus itself, if you can do repairs with Juncus or sedge and get them established, they can be equally as good as using the rock repair. It's hard to get them established, so you'd have to do Juncus through the coir and try to come up with some kind of slope control. Grow your Juncus out before the coir rots out. You got to get your Juncus in place. Okay, this is site number 4. We have some nice native perennial grasses on the slope, but we do have a little head cut or nick point moving up through this area. As we get out away from the tree canopy, we move into an area that has a lot of annual grasses. And the thought is, instead of fixing the head cut, because it has low activity, given that this is a small watershed, that this would be a great area to try a head cut repair by slowing the migration of the head cut from moving upstream by planting native perennial grasses. And so the design calls for an 8-foot wide band up each side and on the bottom with native perennial grass plugs planted 18 inches on center throughout for a length of about 25 feet. And as those get established, they will send down deep roots, become a matrix of deep grass roots through here, and should basically stop the head cut from moving through this area. There is a little bit of risk with this. If we got the 100-year storm and we just planted the grasses, they weren't established yet with their roots, and that head cut ran through, then we would have to reinstall the grasses maybe upstream of that new head cut. But there's no evidence that that head cut's moved very fast in the last couple of years. So trying a perennial grass, this is a very low-tech technique. All right, this is site 5, the downstream most site for this series of projects. This is truly an upland head cut situation. This little drainage area here is actually, you can see it's hummocky, and there's an old landslide here. We have some nick points moving up into the landslide. And if this wasn't controlled during a big storm, we could re-trigger this landslide and put all this fine sediment, maybe 50 to 100 yards of fine sediment, into the tributary that would then work its way down the watershed into our streams where we have fisheries concerns. There's actually 2 head cuts here. There's one at the downstream end and the upstream end. The upstream head cut or uphill head cut here was the most active, and there was enough funding to take on one. So they did a brush check dam here. It is important to work from the downstream up. And if you're doing a series of head cuts and you have to pick and choose, a lot of times we choose the lower, start from the downstream end and fix the lower head cuts and leave the upstream head cuts. The watershed gets smaller as you move up slope. That said, in this case, we had a head cut here right at the base of this landslide. And I know there was some concern, and I think this was a good idea to skip our normal recommendations and move the head cut repair upstream. This head cut repair is using a biotechnical classic brush check dam technique. We usually use these in gullies to collect sediment. In this case, it was a classic brush check dam built right in front of a nick point to control a head cut. It is a layer of 6 to 8 foot long Doug fir branches on the bottom, and then sandwiched on top is a whole layer cake of willow brush. Behind the willow brush is a layer of class 2 permeable gravel, which is the coarse gravel, small gravel, large sand mix. And then they pack some soil in behind that to control the head cut. The idea is the head cut cannot move through that gravel lens, and structurally it's held in place by this willow. There's willow stakes driven through the brush to hold this plug in place, and each one of those could become a tree with water, or if they get enough water through the winter. On this site, we're really lucky to have this drip irrigation system to be able to supplement these projects. On many sites like this, you might want to do this work, say, early December, when the ground's actually wet, and in hopes that you can get some of this willow to survive on its own. This is definitely pushing the limits of where willow will survive. Therefore, in knowing that, the team decided that, hey, we'll do a plug of some sort to stop this nick point, But really the long-term repair at the base of this old slide here is going to be a coyote brush plug. And so up above they planted coyote brush densely, robustly, 18 inches on center. And the idea is that that coyote brush is drought tolerant, it is deep rooting, it's excellent for erosion control, it's really good for habitat. And then that will be the long-term repair and stability for the uphill landslide. Really what we're doing with this brush check dam is, hopefully controlling this head cut for 3 to 5 years while the coyote brush becomes established. On a site like this, you might have livestock or cattle around. Bioengineering is impacted from livestock. Their hoofs during the winter, will punch holes in the coir blanket, or they'll nibble on your repair, your plant material. So a lot of times if there's livestock, we recommend doing a small temporary fence enclosure until your plants are fully established.